Hi kids, Assalamualaikum and very good morning. Today we are going to continue the topic of differentiation. Here we are going to learn how to find the first derivative or how to differentiate ones. In the previous lesson, I have told you that to find the first derivative, there are two methods. The first one by using first principle and the second one by using formula. Now we are going to cover the first one by using the first principle. Before that, let me explain the concept first. Previously, you have learned in the topic of straight line or coordinate geometry to find gradient. Okay, here we have straight line y equals mx plus c with point x1, y1 and x2, y2. Okay, to find gradient, we have formula m equals to y2 minus y1 over x2 minus x1. Okay, actually this formula is to find gradient for the straight line. Okay, now let's say we have curve with point A on that curve. So how to find gradient at point A by using formula m equals to y2 minus y1 over x2 minus x1? Because we only have one point only. Okay, so meaning that we need to consider another one point on the same curve or graph. Okay, so let's consider all this situation. Okay, situation 1, we have point x1, y1, x2, y2. So gradient 1 equals to y2 minus y1 over x2 minus x1. Okay, situation 2, gradient 2, we have coordinate x1, y1, x3, y3. So gradient y3 minus y1 over x3 minus x1. Okay, situation 4, we have smaller. Smaller, you can see here, the triangle becomes smaller size. Okay, so m3 equals to y4 minus y1 over x4 minus x1. Okay, and situation 4, we have smallest triangle. So to find gradient equals to y5 minus y1 over x5 minus x1. Okay, so what do you think? Okay, out of these four situations, which gradient is more accurate to represent gradient at point A? Which one? We have four situations here, okay? So, of course, gradient 4, okay? Of course, gradient 4, because the distance between 2 points is smallest, is nearest, okay? Okay, so here we can conclude that we have to choose the nearest point from A. Okay, so now look at this point A. We are going to find gradient at point A. Okay, so let's say here we have point A. Here is point A. We are going to find gradient at point A. Then we choose another point B nearest to A. Let's say here is B. Okay, now let me introduce. We have delta. Okay, delta represents small changes. So delta x, small changes of x. Delta y, small changes of y. Okay, let's say here we have delta x. Here we have delta y. So meaning that coordinate B is x plus delta x, y plus delta y. Okay, so here by using formula of gradient, we can use the gradient lah. Use formula gradient. Okay, gradient equals to y2 minus y1. So y plus delta y minus y divided by x plus delta x minus x. Okay, you can simplify. We get delta y over delta x. Okay, So we have to choose when we can see here when x approaches to 0. So this one become the gradient. Okay, so this one the gradient dy dx when delta x approaches to 0. So the smallest value. Okay, so limit delta y delta x when delta x approaches to 0. Okay, so here is the formula that we are going to do a lot. We are going to use a lot after this. Okay, now let's do exercise to find first derivative using first principle. First step, you have to add delta y to y and add delta x to x. Okay, here the question y equals to 3x plus 2. So y plus delta y, okay, equals to 3x plus delta x. Okay, so plus 2. Okay, so then we expand. Okay, before that we have to substitute y. Okay, y itself is 3x plus 2 plus delta y equals to expand. Okay, 3x plus 3 delta x plus 2. Okay, so we can cancel off. Okay, we get delta y equals to 3 delta x. So we need to find delta y delta x. Okay, so you've been to the left, you divide both sides with delta x. So we get delta y delta x equals to 3. Okay, so just now we learned that delta y delta x when delta x approaches to 0 is dy dx. Okay, so you find limit both side delta y delta x when delta x approaches to 0, limit 3 when delta x approaches to 0. Okay, limit delta y delta x when delta x approaches to 0 is dy dx. So dy dx equals to 3. Okay, the second example. Okay, again y plus delta y equals to 5 minus 2 x plus delta x. Okay, so we substitute y. Y is 5 minus 2x plus delta y equals to 5 minus, we expand 2x minus 2 delta x. Okay, so 5 minus 2x, we can simplify. So delta y equals to negative 2. Delta x, delta y, delta x equals to negative 2. Find limit delta y, delta x when delta x approaches to 0 for both sides. So limit delta y delta x when delta x approaches to 0 is dy dx, so equals to negative 2. Okay, next one. Okay, we have y plus delta y equals to x plus delta x squared over 5. Okay, so substitute y is x squared over 5 plus delta y, you expand this one. Okay, so x squared plus 2x delta x plus delta x squared over 5. Okay, then we simplify x squared over 5 plus delta y equals to x squared over 5 plus 2x delta x over 5 plus delta x squared over 5. Okay, we simplify. So delta y, so this one we can factorize, okay? Factorize delta x in the big bracket 2x over 5 plus delta x over 5. Okay, so dy dx, delta y delta x equals to 2x over 5 plus delta x over 5. Okay, find limit when delta x approaches to 0. Limit delta y delta x when delta x approaches to 0 equals to limit 2x over 5 plus delta x over 5 when delta x approaches to 0. Okay, so this one 0, okay, so therefore dy dx equals to 2x over 5. Okay, so next, okay, here we have y equals to 2 over x. Okay, so y plus delta y equals to 2x plus delta x. Substitute y is 2 over x plus delta y equals to 2 over x plus delta x. Okay, so delta y is 2 over x plus delta x minus, okay, minus, okay, 2 over x. Here we have two fractions, so to simplify this one, we have to equate the denominator, okay. So all this take over x, x plus delta x. So here we have 2x minus 2x plus delta x. Okay, so simplify here, we get 2x minus 2x minus 2 delta x over x squared plus x delta x. Okay. Okay, we simplify here, we get negative 2 delta x over x squared plus x delta x. Okay, divide, this one is delta y, okay. So delta y delta x equals to negative 2 over x squared plus x delta x. Find limit when delta x approaches to 0. So limit delta y delta x when delta x approaches to 0. So both sides. Negative 2 over x squared plus x delta x when delta x approaches to 0. So this one 0. Okay. So here we have dy dx equals to negative 2 over x squared.